Hello everyone, welcome to the course PH8201 Physics for Civil Engineering. In today's class, we will be dealing with chilled water plant. This is the syllabus for Unit 1. In today's class, we will be dealing with chilled water plant, fan coil system, water piping and cooling load. Chilled water systems are used in medium and large sized buildings. Chiller plants act as a centralized cooling system that provides cooling for an entire building or even multiple buildings. This concept is not new to us. Romans used to run water through the walls to cool the space inside the buildings. In 1926, Carrier invented the first centrifugal chiller, which made it possible to provide large-scale air conditioning for buildings. Chilled water systems provide cooling to a building by using chilled water to absorb the heat from inside the spaces. Chillers use refrigeration cycle to remove heat from the chilled water. So as the name suggests, chilled water acts as the refrigerant. This is the typical refrigeration cycle in which the refrigerant is compressed inside the compressor. The compressor gives the driving force where the refrigerant is taken to high temperature, high pressure. So when it passes through the condenser, it rejects heat to the surrounding and it becomes a high temperature, high pressure liquid. From vapor phase, the transformation to liquid phase happens by rejecting the latent heat of vaporization. In the expansion valve, which is usually a narrow orifice, the liquid at high temperature, high pressure undergoes throttling. So when the liquid is allowed to expand through a narrow orifice, there is cooling and the liquid becomes a low temperature, low pressure liquid plus vapor. That is, it is called wet vapor. So the wet vapor on passing through the evaporator absorbs heat from the surrounding space, which is usually within the building, and on absorbing the heat, it gets converted into dry vapor, low temperature, low pressure vapor. So this vapor is again taken to the compressor and the cycle repeats. So the liquid is taken through a closed cycle, closed loop, and there is cooling where the evaporator coil is present and the heat is rejected out where the condenser coil is present. Evaporator and condenser are usually heat exchangers, whereas the compressor does the work and at the expansion valve there is throttling. So this is a typical refrigeration cycle. So in chilled water system, this is the schematic for a chilled water system. You have the refrigeration cycle here and the condenser is connected to the cooling tower. So this is the cooling tower with levers present where the hot water is passed through the cooling tower and due to direct mixing it turns out into cold water. The cold water is fed into the condenser pump and that's how the condenser works. Whereas on the evaporator side, you have the load, that is the space which has to be cooled, that is within the building. So within the building, the supply water is cold water, which on passing through the load gets heated up and by absorbing heat and it is fed into the chilled water pump which again goes to the evaporator. As I told you earlier, condenser and evaporator are both heat exchangers. So this is how a chiller plant with a cooling tower and air handling unit works. The air handling unit is sometimes replaced by the fan coil unit, because it is through the air handling unit that the building space gets cooled. So as you can see from the cooling tower, the cold water is fed into the chiller unit where the refrigeration cycle takes place, and the cold water at around 12 degrees Celsius is fed to the air handling units where fans are used to exchange the heat from the building spaces to the water. So the chiller water which is flowing into the building is at 6 degrees Celsius, whereas the chiller water which flows out from the air handling unit is at 12 degrees Celsius. That is how the cooling takes place over large spaces. And the chiller water is taken back to the refrigeration cycle where the cooling occurs from the cooling tower, as we have seen earlier. This is how a typical chiller plant works. So the components of a chilled water plant are a chiller, air handling unit, cooling tower and pumps. So there are air-cooled chilled water plants without cooling towers. So usually in air-cooled chilled water plants, the chiller pumps along with the fan coil units does the work. So a fan coil unit is again a heat exchanger. So in a fan coil unit, there are fans that is used to transfer the heat from the space within the building to the chilled water. Fan coil units remove the unwanted heat from the building and transfer it into the chilled water loop. The chilled water will enter the fan coil unit at around 6 degrees Celsius, as we saw earlier, and due to the transfer of heat, the temperature rises to around 12 degrees Celsius. That is, in Fahrenheit scale, it is the temperature rises from 42 degree Fahrenheit to around 53 degree Fahrenheit. Let us now let us now discuss about heat exchangers. Why have we to discuss about the heat exchangers? As you can see in the refrigeration cycle, heat exchange occurs at the evaporator and condenser. While heat is rejected to the surroundings at the condenser, heat is being absorbed from the refrigerated space or the space to be cooled at the evaporator. So both evaporator and condenser are heat exchangers. Hence, we will have a short discussion about the heat exchangers. So, heat exchangers can be transfer type heat exchanger as shown. Two concentric tubes, hot and cold fluids are allowed to flow. If both the cold as well as the hot fluid flow in the same direction, then such heat exchangers are called parallel type, parallel flow transfer type heat exchanger. If the hot fluid and cold fluid flow in opposite directions, then that is called counter flow transfer type heat exchanger. Since the two fluids are not allowed to mix, only transfer of heat occurs across the separating walls. Since the refrigeration cycle, as we are aware, is a closed cycle where the refrigerant is allowed to flow in a closed cyclic loop, mostly the evaporator and condenser are transfer type heat exchangers. There is another type of transfer type heat exchanger as can be seen here in the shell tube type condenser or the counter flow type heat exchanger. So in counter flow type heat exchanger, one fluid is allowed to flow through the tubes in one direction, whereas the other fluid flows this cross flow type heat exchanger, where one fluid is allowed to flow in one direction while the other fluid flows in a perpendicular direction or in a cross direction. So such heat exchangers in which the fluids flow in mutually perpendicular direction are called cross flow transfer type heat exchangers. And in case of air handling units or fan coil units, there are motorized fans present near the cross flow type heat exchanger. In cross flow type heat exchanger, there are fans present near the cross flow type heat exchanger in order to enhance the transfer of heat. This is how the fan coil units or air handling units increase the rate of heat transfer from within the building to the chiller water. There is a third type of heat exchanger called the direct mixing type heat exchanger as in a cooling tower. So jets of stream of water is sprinkled into the cooling tower where there are wooden planks present which increase the path of flow of the water. At the bottom of the cooling tower, there are levers which are like windows which increase the airflow from outside the tower to the inner part of the tower. Due to direct mixing of the hot water and the cold air, the water gets cooled and this cooled water is taken back to the closed cycle. So such a heat exchanger is called direct mixing type heat exchanger, where the hot water and cold air are allowed to mix. Hence, as can be seen, the water piping in case of transfer type, parallel flow, counter flow, cross flow or shell tube has to be in a concealed manner so that the mixing of fluids don't occur. Whereas in case of direct mixing type, the piping can be in open fashion. So Water piping is another important factor that we should concentrate on in a chilled water plant. The piping is usually made of steel, copper, or plastic. Piping is usually closed type, except in case of cooling tower where the piping is open type. And the piping should be such that it withstands a static pressure of around 150 psi. Cooling load. Cooling load is defined as the total heat required to be removed from the space in order to bring it to the desired temperature by air conditioning and refrigeration equipment. The purpose of a load estimation is to determine the size of the air conditioning and refrigeration equipment that is required. So for a small space, around 1.5 ton AC is enough, whereas for large buildings, we need around 15 ton ACs. The design load is based on the inside and outside design conditions. So in today's class, we have explained the working of a chilled water plant, described the functioning of fan coil system, we have discussed about water piping, and we have defined cooling load. Thank you for your attention.